Dear learners, welcome to the online course of Engineering Chemistry. From today onwards, we will start the Green Chemistry unit. In today's video lecture, we will cover the following topics: introduction about this unit, definition, key objectives of green chemistry, need of green chemistry versus environmental chemistry, and after that basic part we will going to discuss the principles of green chemistry. We know that there are 12 principles of green chemistry, out of which 12 principles. In today's video lecture we will discuss the two principles, that is prevention of waste, and second one is the atom economy. So let us begin with the introduction part. We know that with the rapid advancement of science and technology, the chemical industry has grown tremendously, but often at the cost of the environment and the human health. So the traditional chemical practices have led various problems such as air and water pollution, soil pollution, generation of hazardous and toxic chemicals into the environment, depletion of natural resources, and the various health issues due to release of these toxic chemicals in the environment. So these are the basic problems occurring due to the large use of chemicals and release of toxic chemicals in the environment due to the basic traditional chemical practices. So, to address these issues, the concept of green chemistry was introduced in 1990s as a proactive approach to reduce the environmental and health impacts of chemical processes. So basically, the green chemistry focuses on prevention of pollution at the source itself by using the safer chemicals and the solvents. It focuses on design products that are biodegradable and that are the non-toxic chemicals. It focuses on increase energy and material efficiency. So basically, by adopting these three aspects, the green chemistry reduces the environmental and health impacts of the various chemical processes. Definition of green chemistry. Paul Anastas and John Warner introduces the green chemistry and define it in 1991. According to them, the design of chemical products and processes that reduce or eliminate the use and generation of hazardous substances are known as the green chemistry. So basically, green chemistry focuses on designing of chemical products and designing of chemical processes that reduces the generation of hazardous substances into the environment. It is also known as the sustainable chemistry. It aims to make chemistry safer, cleaner, and more efficient. So basically, the green chemistry approach is used to design safer, eco-friendly, and efficient chemical processes which reduces the hazardous and toxic chemicals in the environment. So the basic key objectives of green chemistry includes water prevention, safe products, energy and resource efficiency, use of renewable resources, cleaner production technologies, design for product degradation. That means designing of such products that degrade easily in the environment. So no accumulation of these type of products in the environment taking place. Now, the green chemistry focuses on making chemical processes environmental benign. That means friendly to environment, economically viable, means the cost effective processes, and socially responsible. That means the chemical processes are designed in such a way that their negative impact on the human beings and on the all living beings will be reduced. So now question comes to our mind that why the need of green chemistry is. So there are various parameters due to which the green chemistry is in need, which includes the sustainable development, because we know that the green chemistry concept supports the UN sustainable development goals for future generation. So it is very useful. Environmental protection. The green chemistry focuses on reduction of the pollution and it promotes the non-toxic materials, safer processes, the minimization risk and accidents in the chemical reaction. Human health, it minimizes exposure to toxic chemicals. Innovation, it drives eco-friendly technologies and products. Regulatory compliance, it helps industries to meet environmental laws. Resource conservation, the green chemistry encourages renewable resources and its efficiency. Economic benefits, it lowers the cost through waste and energy reduction. So basically, these are the parameters due to which the green chemistry is essential or it is in need. Now, often we mistake when we are talking about the green chemistry, we are confusing it with the environmental chemistry. The green chemistry and the environmental chemistry are the different things. Basically, the green chemistry approach is a preventive approach, while as environmental chemistry approach is the treatment approach. That means the green chemistry is the proactive approach which prevents pollution at the source itself, while the environmental chemistry is the reactive approach which treats existing pollution. That means after the pollution occurs, the environmental chemistry focuses on treatment of that pollution, while the green chemistry focuses on to minimize the pollution at the source itself. That means before the toxic chemicals or harmful substances releasing in the environment, the green chemistry works before the pollution, while the environmental chemistry works after the pollution. That means it treats the pollution, while the green chemistry is the proactive approach. It minimizes the pollution before it will occur. So the environmental chemistry deals with various facets of pollution, degree of pollution, treatment of pollution, etc. While the green chemistry focuses on prevention of pollution at the source itself. Now, coming towards the principles of green chemistry, there are 12 principles on which the green chemistry is based, which includes prevention of waste, atom economy, less hazardous chemical synthesis, designing safer chemicals, safer solvents and auxiliaries, design of energy efficiency, use of renewable feedstock, reduce derivatives, catalysis, design for degradation, real-time analysis for pollution prevention, inherently safer chemistry for accident prevention. So these are the basic 12 principles of green chemistry. Through these principles, the green chemistry achieve its goal, that is to reduce the incorporation of harmful or hazardous chemicals in the environment. So in this lecture and coming few lectures, we will cover all these 12 principles of green chemistry in detail. So let us begin with the first principle of green chemistry, that is prevention of waste. It is always better to prevent waste than to treat or clean up the waste after it is formed. So this principle emphasizes that it is better to avoid waste generation than to treat or clean it up afterwards. That means before the chemical releases in the environment, we must take efforts on the processes that these chemicals must not be released in the environment. For example, in the manufacturing industry, in pharmaceutical manufacturing, replacing multi-step synthesis, which generate lot of different type of solvents waste in the environment. These multi-step synthesis can be replaced by the one pot or catalytic processes, which can prevent waste formation, because when we carry out any chemical process in multi-step synthesis, in each step there is a large wastage of solvents in the environment. So to prevent these wastage of solvent in the environment, we can replace these multi-step synthesis in the one pot synthesis method or by the catalytic processes synthesis method. In this way, we can reduce the release of harmful solvents in the environment. Second best example for this is water-based paints. In traditional paints, use of volatile organic compounds that evaporates into the air and pollute the environment. So we can replace these traditional paints by the green alternative, that is water-based paints. These water-based paints avoid the use of volatile organic compounds, therefore these reducing the air pollution and hazardous waste. So basically the prevention of waste focuses on to avoid the waste generation. That means it reduces the process in which the harmful chemicals are mixed up into the environment at the source itself. So basically we can modify the process to reduce the waste generation in the environment. The second principle is the atom economy. What is atom economy? The synthetic methods should be designed to maximize the incorporation of all materials used in the process into the final product. That means all the atoms present in the reactant molecules must be converted into the product. No byproduct is formed. So the atom economy principle focuses on maximizing the incorporation of all the atoms from starting materials or the reactants into the final product. So all the atoms present in the reactant molecule shall be in the product molecules, so that no byproduct is formed and waste is generated in the and no waste is generated in the reaction. For example, if two reactants A plus B combining, so these must be converted into C. That means all the atoms present in the A and B are in the molecule of C. So no byproduct is formed in this reaction. If no byproduct is formed, that means no extra product is released as a waste in the reaction. So this is the basics of the atom economy principle. The atom economy principle basically maximize the material incorporation. It ensures all the materials are incorporated into the final product. It design efficient methods to develop synthetic methods that optimize material use. So basically, atom economy focuses on designing the efficient methods for the synthesis. It improves economic viability because the atom economy principle enhance the economic benefits of chemical processes. It enhances the reaction efficiency because it improves the efficiency of the chemical reactions. Obviously, it reduces the waste generation because all the molecules or atoms present in the reactants converted into the products. That is why no byproduct is formed. It promotes the sustainability because it fosters sustainable practices in the chemical manufacturing. So basically, the atom, when we following the atom economy principle, all these aspects we can achieve. So the green chemistry promotes the use of synthetic methods such as addition and rearrangement reactions that improve atom efficiency. By designing the reactions with high atom economy, chemists can reduce the waste at the molecular level, making processes more sustainable and the cost effective. So by this formula, we can calculate the atom economy of any reaction. Atom economy is equal to molecular mass of desired product divided by sum of the molecular masses of all the reactants multiplied by 100. So this is the formula through which we can calculate the atom economy of any reaction. So let us take the example of one addition reaction. Ethene plus hydrogen gives ethane, right? So molecular formula of ethene is C2H4 with the molar mass 28. Molecular weight of hydrogen is 2. Molecular weight of ethane is C2, formula is C2H6, and molecular molar mass is 30. So by incorporating all these weights into the atom economy formula, that is molar mass of product divided by molar mass of all the reactants multiplied by 100. So what is the product here? Product is ethane and molar mass of ethane is 30. So we are putting here 30. Now reactants are ethene and hydrogen. So molar mass of ethene is 28. Molar mass of hydrogen is 2. So by putting these molar masses, we are calculating that atom economy of this reaction is 100. So what 100% atom economy shows? It shows that all the atoms from reactants end up in the product. That means 100% atom economy is achieved, and in such case no byproduct and no any other chemical released in the environment. Only the only product is the desired product which we want to synthesize. So this is the best example of high atom economy reaction, that is the addition reaction. Another example is the substitution reaction. Let us take the example of chloromethane plus NaOH, sodium hydroxide, gives methanol and NaCl in the reaction. So by incorporating the atom economy formula, the product is the desired product is the methanol. So we are putting here the molar mass of methanol, that is 32. Reactants are chloromethane and NaOH. Molar mass of chloromethane is 50.5 gram per mole. We are putting it here, and the molar mass of NaOH is 40. So we are putting the 40 here. By calculating atom economy using this formula, we get the atom economy for this reaction is 35.4%. One should note that in while calculating the atom economy, the product molar mass is to be used, the main product molar mass, not the byproducts molar mass we should include. So here we are we are using the molar mass of methanol only, because in this reaction methanol is the main product, NaCl is the byproduct. So only the molar mass of main product is using in this formula. So by using this formula, we are obtaining the atom economy 35.4%. So only about 35% of atoms are incorporated into the desired product. The rest form NaCl, that is the byproduct, which is released as a waste product in the chemical reaction. So we can say that this is the lower atom economy reaction. So the green chemistry principle not promote such type of reactions with the lower atom economy. Let us take the another example, that is esterification reaction. In the esterification reaction, ethanoic acid reacts with ethanol to form ethyl ethanoate and the water. Here the main product is ethyl ethanoate. So we are taking the molar mass of ethyl ethanoate in the formula of atom economy, which says the molar mass of product divided by molar mass of reactants into 100. So molar mass of product is ethyl ethanoate, molar mass, that is 88. Molar mass of reactant is molar mass of ethanoic acid, that is 60. Molar mass of ethanol, that is 46. So by putting these values in the atom economy formula, we are obtaining the atom economy for this reaction is 83%. So about 83% of atoms in the reactants end up in the products. So, and the rest are in the form of the water as a byproduct. So it is fairly good atom economy reaction, acidification reaction. Another good example of keeping atom economy is green synthesis of ibuprofen by the boot process. Compared to the older methods, the boot process significantly reduces the number of reaction steps and chemical waste. Traditional routes had lower atom economy and generated more harmful byproducts, making them less sustainable. So, the boot process is considered as the green chemistry approach because it includes less step, higher yield, and about 99% atom economy as compared to the older traditional route of the synthesis of the ibuprofen. So basically what we want to say that by following the principle of atom economy, we can reduce the generation of waste in any type of chemical reaction. So now time for the learning check. Please read the question displaying on your screen and think about its correct answer. Which of the following best describe the primary goal of green chemistry? A. To increase the use of toxic chemicals in industrial processes. B. To develop chemical products and processes that reduces or eliminate hazardous substances. C. To enhance the color and appearance of chemical products. D. To promote the use of non-renewable resources in chemical manufacturing. Yes, you are right. The option B, that is to develop chemical products and processes that reduces or eliminate hazardous substance, is the best way to describe the primary goal of the green chemistry. So that's all for today's video lecture. Please like and subscribe the channel for getting such video lectures on the interested topics. Thank you.